Okay, welcome to our discussion on Chapter 8, Codes and Specifications. Uh, Before we begin the discussion, we can take a look at some online imagery. A lot of people don't realize this, but engineering, when we hear the term engineering, it probably brings something specific to our mind. But look at the root word engine, right? So, engineering, in a modern sense, really began to take a grab on things and to want to start refining mechanical things around the time that steam engines became a primary method of transportation around the world. So what we see here is we see what happens when a steam engine, a steam train boiler explodes. Pretty attractive, huh? Wouldn't you say? So this was a pretty not uncommon occurrence back in the day because there were no specifications, there were no codes, and often you'd have explosions and we'd have people dying and we'd have property damaged and destroyed because there wasn't one unified set of rules that people followed in the manufacture of steam trains. So, at some point, somebody said, look, we have to figure out what works and what doesn't work, and we need to set this down in writing so that we can stop having these horrific accidents with loss of life and property. And really, that is one of the steps in modern engineering that brought us to where we are today in the world of engineering. So, steam engines led to engineering, and engineering involves setting down some rules so that things don't blow up when we don't want them to. Okay, so that's our discussion on codes and specifications. Specifications are called specs for short sometimes. Specifications are very specific guidelines that need to be followed in order to have expected outcomes. And specifications also allow us to have uniform results. So if we do it this way, we can expect this outcome. And if we do it this way, we can expect this outcome. And these things, through trial and error, have been developed over time so that we have a unified group of rules and procedures so that things don't explode, which is, of course, we're not working with steam train boilers, but we are working with high temperatures and high pressures quite often in process piping. So, designers use specifications when they are deciding, am I going to use standard weight pipe? Am I going to use extra strong pipe? Am I going to use double extra strong pipe? Fabricators use specifications when it comes time to weld things. What kind of bevel do we need if we're going to do butt welds? How much root gap are we going to leave between the pipes when we do our welds? And then specifications are also involved in planning and purchasing and in marketing and in sales. Specifications allow us to price a job out. Specifications are usually arranged for process piping based on three things. What is going through the pipe? What's the commodity? How much pressure is the pipe under? And what temperature are we operating at? So specification allows us to select the right parts to do the job without blowing up. And when you take all of these suggestions and recommendations and put them together, what we get is something called a specification class. So here's some examples of specification classes. The class is A15. A15 relates to when we are working with 150-pound raised face flanges in a carbon steel process system. Now, if we were working in 300-pound pressure, right, the specification class for that, the group of rules associated with that is called Class C30. Again, it relates to a 300-pound system with raised face flanges, carbon steel, and again, it's a process system, maybe fractionation, maybe distillation. Right now, other processes have different requirements, so there are a bunch of specification classes, and here's just a few of them. Class CW15 relates to when we're working with cooling water, right? So it's still carbon steel. It's still at 150 pounds of pressure, but it's got different requirements to move cooling water through the system than it would for moving around, for example, crude oil to a fractionation column. So if we know what the name of the class is, we can then go to a book or a chart and get some specific information about how things are going to be put together. Let's take a look at the A15 class, for example. Here is the piping A15 specification class. It tells us that the expected pressure rating is going to be at 150 pound for our valves and our flanges. The material is carbon steel, and then there might be a whole bunch of stuff down here we're not really familiar with. So let's take a little time and go through here and have a look and see what this does. And of course, you can look on page 160 in your text if you'd like to follow along. Corrosion allowance means how much of the pipe or the fitting can get worn away before we need to replace it. So for this specification, what we're also looking at are the temperature this system is expected to run under and the pressure is expected to run under. We have degrees Fahrenheit. It has been designed for a 350 degree system, but the expectation is while it's been designed for that, it's going to operate at a lower temperature. And PSIG, pounds per square inch gauge, just means pounds per square inch at sea level. Again, it's been designed to operate at around 200 pounds of pressure. Actual operating pressure will be a little bit lower. So we always over-design it a little bit based on the fact that, well, we might exceed this occasionally by a little bit. We don't want things blowing up. Okay, so this is the top part of our specification, some basic information about what is going to be expected for this kind of a system. Let's go into our next discussion then. What is all this stuff down here?